So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Elon Musk wasn't talking about any robot, but specifically Optimus V3. Unlike its earlier versions, V3 combines a full redesign with unmatched affordability. It's lighter, faster, smarter, yet priced shockingly low. What makes this generation uniquely capable of breaking the cost barrier? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about TeslaBot, Tesla EVs, and the latest news. What makes the new Optimus V3 significantly cheaper to build than its predecessor? Is Tesla's latest Optimus Gen 3 truly capable of maintaining a competitive price when technology is becoming increasingly complex and materials ever more expensive? This question is on the minds of investors and potential customers alike, especially when Elon Musk once announced the goal to price the robot at just $20,000. Yet with a host of technical upgrades just announced, from a carbon fiber chassis and redesigned mechanics to advanced processors and a premium LED face, one wonders if that price point remains achievable. To answer, we must analyze each key component of Optimus V3 and compare with previous versions and current humanoid robot price ranges. First is the bespoke carbon fiber frame, a major improvement allowing the robot to shed as much as 37 pounds, optimizing energy use and overall mobility. But carbon fiber is not cheap. On the open market, this material can cost 5 to 10 times more than aluminum or lightweight steel used in Optimus V1 and V2. If the frame accounts for around 15% of total production cost, simply switching to carbon fiber could add $1,500 to $3,000. That means Tesla must recoup those costs elsewhere, or leverage massive production efficiencies to stay under $20,000 total. Next is the redesigned hands, the biggest highlight of V3. Featuring 11 degrees of freedom, the robot can now perform delicate tasks such as twisting a bottle cap, holding an egg without cracking it, or balancing tiny components. Compared to Gen 2's 6 degrees of freedom, this is a quantum leap technically. However, the added complexity, miniature motors, force sensors, micro drivetrains, can cost $3,000 to $5,000 per pair in low-volume production. Fortunately, Tesla's advantage is scale. With plans to build tens of thousands of robots by 2025 to 2026, unit costs for these components could shrink to $1,000 to $1,500 if the supply chain is optimized. Another cost driver is the 600 nits LED face screen. Not just for expressions, it includes sensors for gaze direction and user interaction. Although it seems modest in size, such screens cost $150 to $300 each at low volumes. In mass production, prices may fall to $50 to $100, but it remains a step up from the blank plastic face used in earlier versions. Tesla also equips the Optimus V3 with a dedicated AI processor, likely a variant of the full self-driving FSD chip that can perform millions of calculations per second and update expressions within 80 milliseconds. A chip this capable might cost $500 to $800 on its own, not including heat dissipation, onboard memory, and control circuitry. It's both a strength and a pricing challenge for Tesla, who must standardize such powerful hardware at scale while keeping price expectations realistic. Beyond these headline features, the total hardware cost includes gearbox modules, main actuators, built-in force sensors and joints, high-capacity lithium-ion batteries, and auxiliary structural components. These mechanical systems are estimated to account for roughly 40% of manufacturing cost. If Tesla maintains high automation levels and uses gigafactory-style presses, similar to Model Y production, mechanical costs might stay under $7,000. But if early versions require manual assembly, costs could exceed $10,000. By contrast, Optimus Gen 2 was estimated to cost $30,000 to $35,000 to produce. With V3, Tesla is approaching the targeted $20,000 threshold by cutting labor costs, reusing auto-sourced systems, and adopting the very successful gigafactory manufacturing model. Still, much depends on volume. If Tesla manufactures only a few thousand units, a $20,000 price point seems unlikely. But if production scales to 10,000 to 50,000 units per year, each robot's cost might drop by $5,000 to $10,000 through economies of scale. Another factor, Tesla could choose to sell or lease robots. If they adopt a subscription model, leasing Optimus for $1,000 to $2,000 per month. They need not be overly strict about sticker price. This makes the technology accessible while ensuring lifecycle revenue per unit may exceed tens of thousands of dollars. Such a strategy also protects Tesla's brand from comparisons with China's low-cost robots. Speaking of which, companies like Fourier Intelligence or UB Tech are releasing humanoid robots in the $15,000 to $20,000 range. Tesla must therefore maintain high quality while controlling price. As Musk argued, the core issue is designing everything from first principles, no copying. That means Tesla can produce a higher performance robot, but they must justify it through price. Otherwise, they risk losing market share to low-cost alternatives from China. In short, Optimus V3 represents a dramatic leap in design and technology, but also presents a complex economic puzzle for Tesla. Each new hardware feature adds cost, from the carbon fiber frame and dexterous hands to AI processors and expressive LED faces. Unless Tesla quickly achieves large production volumes to reduce per-unit cost, the target price of $20,000 may remain merely aspirational. The real question now is not just how much will Optimus V3 cost, but rather, can Tesla move fast enough to deliver a high-performance robot at a consumer-level price before low-cost rivals dominate the market? Once again, please help us reach 15,000 subscribers. This is important for us to stay motivated. Thank you. How does mass production help reduce the price of Optimus V3? When Elon Musk hinted at the possibility of selling the Optimus V3 for under $10,000, the tech world raised a major red flag. Can Tesla really deliver such a shocking price point, especially when most humanoid robots today cost between $70,000 and $200,000? Yet if we closely examine Tesla's entire value chain for Optimus, from raw materials to manufacturing, design, distribution, and market strategy, this scenario is not only plausible, but grounded in solid economics. First, Tesla's biggest advantage over competitors is its vertically integrated supply chain. Few robotics companies can match Tesla's ability to control every critical component. Custom-designed FSD chip, in-house battery production at Gigafactory Nevada and Texas, electric motors, and AI control systems, all developed or directly managed within Tesla. This significantly reduces middleman costs that companies like Boston Dynamics or Agility Robotics must pay to external suppliers. For example, an off-the-shelf lithium-ion battery pack for a humanoid robot can cost $2,000 to $5,000. But Tesla's 4680 cells produced at scale can cut that cost to below $1,000. Similarly, the FSD chip that powers Optimus, already used in Tesla vehicles, can be manufactured for only a few $100s instead of the thousands a competitor would pay to license chips from NVIDIA or AMD. Tick control over these core components gives Tesla unmatched economies of scale. Software is also streamlined. Rather than developing a custom robot operating system from scratch, Tesla leverages the self-driving software it has developed over a decade. That saves massive R&D costs. The neural networks trained on billions of miles from Tesla's car fleet adapt well to Optimus, avoiding the need for building entirely new datasets. Furthermore, adopting a mass production model, like Tesla's Gigafactories used for EVs, could drive Optimus V3 well under $10,000 per unit. Musk has repeatedly stated, with enough volume we could price the robot even less than a used car. This is not just rhetoric. If Tesla achieves production of between 100,000 and 1 million robots annually, unit costs will shrink dramatically through automation and streamlined designs. Optimus V3 already reflects this trend. A lighter, carbon frame, modular arms and legs with fewer parts, and wrist and hand mechanisms optimized for quick assembly. These design simplifications reduce robot components by more than 30% compared to Gen 2, reducing assembly steps, errors, and labor costs. Built-in self-testing and robotic assembly further reduce workforce requirements. The goal of pricing Optimus under $10,000 isn't merely competitive, it's strategic for mass adoption. At that price point, small businesses could employ one robot for warehouse tasks, inspection, or heavy lifting instead of hiring labor by the hour. Even middle-income households might consider owning a robot for household chores or elderly care. This could trigger a new consumer market, similar to how smartphones became ubiquitous when their prices dropped below $500. Importantly, Tesla doesn't need high per-unit profit early on. Like it did with the Model 3, the company is willing to accept low margins, or even break even, in the early phase to capture market share and accumulate real-world data. Each Optimus unit becomes a live data source that enriches Tesla's AI models, data more valuable than any hardware revenue. With millions of robots operating 24/7, Tesla gains access to proprietary data no other company can match, fuel for an unbeatable AI advantage. In summary, the vision of an Optimus V3 priced under $10,000 isn't just hype. It stems logically from Tesla's strategic choices. By controlling critical components, optimizing manufacturing, sharing software with its EV division, and pursuing aggressive market strategy and data collection, Tesla is building toward a future where Optimus could become a mass-market product. When that future arrives, the question won't be if, but when, you'll have a personal robot at home that costs less than a new premium motorcycle. Why does mass production matter for Optimus V3's price? While many robotics companies struggle to control costs due to fragmented supply chains and dependence on third-party vendors, Tesla has a unique advantage: vertical integration. Tesla's strategy of building everything in-house, from batteries to AI chips, grants it a level of cost efficiency and scale that no other robotics firm can match. This approach not only slashes production expenses for the Tesla bot, but also sets the foundation for long-term dominance in the humanoid robot industry. One of Tesla's most powerful cost-cutting tools lies in its vertically integrated manufacturing ecosystem. Unlike competitors like Figure AI, Boston Dynamics, or Agility Robotics, who often outsource parts like actuators, sensors, chips, and powertrains, Tesla produces nearly all core components internally. The Tesla bot shares major hardware elements with Tesla's existing vehicles, such as electric motors, battery modules, and thermal management systems. Elon Musk confirmed that many Optimus actuators are now built on the same supply lines used for the Cybertruck. This reuse of proven mass-producible components dramatically reduces unit cost. For example, Tesla has already achieved economies of scale with 4,680 battery cells, which power not only Model Y and Cybertruck, but are now integrated into Optimus. This eliminates the need to source expensive low-volume batteries, a major bottleneck for other robotics startups. Additionally, Tesla designs its own AI hardware, including the full self-driving FSD computer, which powers both its vehicles and the Optimus brain. With full control over chip design, thermal engineering, and board integration, Tesla avoids licensing fees and expensive third-party contracts. More importantly, the company leverages its custom-designed Dojo supercomputer to train the Tesla bot using real-world visual and tactile data. This vertically integrated AI training pipeline stands in stark contrast to smaller firms that must rely on costly cloud services or external computing clusters, which increase their operational costs and limit scalability. Tesla's battery strategy further strengthens its cost leadership. By manufacturing lithium-ion batteries in-house through its gigafactories, Tesla not only ensures a steady supply for its robots, but also avoids price volatility seen in the broader EV or electronics industry. Furthermore, the company's decision to move away from rare earth materials in electric motors reduces both geopolitical risks and material costs. In fact, Elon Musk emphasized that Optimus uses no rare earth elements, which is a massive cost saver at scale and gives Tesla greater independence from Chinese supply chains. Another massive advantage Tesla holds lies in software training. Traditional robotics firms often spend tens of millions labeling datasets manually to teach robots how to interpret the world. Tesla, in contrast, benefits from billions of real-world video clips collected through its global vehicle fleet. These clips serve as foundational training material not just for FSD, but also for Optimus. Even better, once deployed, each Optimus robot becomes its own data generator, collecting, labeling, and uploading real-world interactions back to Tesla's AI training loop. This closed-loop system allows Tesla to exponentially reduce the marginal cost of AI development over time. It's the same principle that helped Tesla FSD evolve faster and cheaper than legacy automakers' autonomy efforts. Tesla also has the rare ability to validate and improve its robots in real-world settings, its own factories. Elon Musk revealed that Tesla already has multiple Optimus units performing simple tasks like moving parts between workstations or organizing tools. This internal deployment eliminates the need for expensive testing labs or slow customer pilots. It also generates immense cost savings. Tesla doesn't need to pay a third party to gather feedback, nor wait for customer rollout cycles to iterate on design. Instead, the feedback loop is instant, internal, and fully under Tesla's control. Another cost advantage competitors simply cannot match. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.